Amazing. We are live. Hello, everyone. Welcome to the second webinar in the series of Kubernetes cost management that we are doing right now. I just quickly check whether we are live on all the platforms because we are streaming on multiple platforms today, which is good. I'll just quickly reload LinkedIn. Okay, LinkedIn is good. And I think YouTube looks good as well. Amazing. So just a heads up, we are live streaming on LinkedIn and YouTube simultaneously. So if you wish to chat with us, because I feel it's a bit easier to chat on YouTube, feel free to join the YouTube live stream as well. I'll just quickly drop in the link for you all for those who are joining from LinkedIn. And yeah, awesome. So again, welcome to this particular webinar and this particular series. In the first one, we covered what are the essentials when it comes to Kubernetes cost management. What are the essential topics that you need to know in order to get started, in order to just try to implement Kubernetes cost management in your organization. And in the second webinar, which is this one, we are going to talk about the next big question, which is why managing costs in Kubernetes is a challenge, right? We are going to go over through a couple of challenges that we have seen in the community. People have been talking about it, and organizations are facing this. And before moving on to the strategies, I think it's important that we understand what are the roadblocks that you may face through the path of applying Kubernetes cost management. So this is something that we are going to discuss. I'll quickly share my screen and we can get started. By the way, whoever is joining this webinar would love to know from where you are joining from. So you can write a hey in the chat and let us know the place where you are joining from. Awesome. So let's start. Just to quickly give you all a bit of an introduction. Hi, my name is Kunal. I'm working as a DevRel engineer at Randoli. Super excited to have you here. I'm also a CNCF ambassador, and I love talking about cloud native and tech. So feel free to reach me out if you ever want to have a conversation around observability, cost management, or in general cloud native. I'll be happy to have a conversation with you. And joining with me is Rajith, CTO at Randoli. Rajith, thank you so much for joining me here today for this webinar. Would you like to tell everyone a little bit more about yourself and what you are doing these days?
Yes. First of all, welcome to all of you. Thanks for making the time to listen in. My name is Rajith. I'm this founder and CTO for Randoli. Hi, Siddha. And these days I'm focusing a lot on open telemetry. Observability is one of my sort of passion projects these days. And Because of the nature of Randoli's product focus, cost management and observability are some of the key things that are working these days.
Amazing. Yeah, thank you so much. And by the way, Rajat joined me in the first webinar itself because we are running the series together. Talking about the first webinar, again, I'd like to give a shout out to the series that we are running. So this is Kubernetes Cost Management series. And in each webinar, we are tackling one aspect of Kubernetes cost management, sort of trying to educate you and helping you in order to implement cost management strategies in your organization. In the first one, we covered the fundamentals. Today, we are covering the challenges. And in the next set of webinars, we'll be talking about different strategies that you can implement. So if you missed, if by any chance you missed the previous webinar, you can scan this QR code that is visible on your screen, which will lead you to a playlist. These will be recorded. We are recording this, so it will be available for you to watch on our YouTube channel. But we recommend attending it live because nothing is better than live stream. You'll be able to interact with us, right? Cool. I think we can start. So just to set the stage, right? And let's answer and try to set the stage with answering the elephant in the room itself, which is why managing cost in Kubernetes is still a challenge. And I'll come to the point why I'm mentioning still, because if you look at these reports right now on the screen, I hope it's visible to you all. These numbers are from very recent reports by the CNCF. This one on the left-hand side is from SysDig. These two are from the CNCF reports. And all these numbers and reports keep showing the same thing, which is organizations tend to set the container with no limits. CPU and memory are going unused. That means resources which are actually getting provisioned and which you are paying for, you are not actually using them, right? And overall, what we are seeing in the industry is organizations on a general scale are overspending by as much as 40% over an year, which is a really huge number, right? The point that I want to make this, because this is something we discussed in the first webinar as well, there is awareness of this particular topic. I was fortunate enough to attend KubeCon last year, and there were a lot of conversations I had with people, and cost management was one of the major topics that was being discussed there, right? So there is awareness. People know cost is an issue and they want to implement cost management, but there is still a gap between this awareness and how much organizations are actually saving, right? So I think today, Rajit, we'll tackle this particular gap and try to understand what are the roadblocks that organizations and engineers are facing right now. But just to set the stage, in your experiences and looking at these similar numbers throughout the community and through the conversations you have had, why do you think this is happening? And despite the awareness, why managing costs in Kubernetes is such a huge challenge for companies and organizations?
Um, that's a great place to start, and let me also, add a couple of points about what you just mentioned, and then we will talk about this because I just before the webinar I got off a call with someone else, with a customer who's actually explained some of the cost management challenges that they have, despite having visibility, despite having tools, why it's not that easy to do it, right? And then last week I was at KubeCon. I also was at SRE Day doing a talk on cost management, and what we noticed was that a lot of people, despite being aware, is still struggling sometimes with like figuring out how to do like how to implement these strategies. So that's what we want to talk about today, right? So let's tackle a couple of questions, right? Like, so you're coming from a VM in the world into Kubernetes. Now all of a sudden you have to grapple with some of the um, containerization related concepts, right? So what you ended up doing on the VM side is different from the container side, because when you generally you end up running one type of application in a virtual machine for security reasons and for isolation and all of that stuff. So in terms of wrapping your head around the cost, it's easier. Like, these VMs are assigned to these particular applications, so you were able to figure out in a certain way how much each application is costing, and any issues around it. And generally, I mean, there are easy to have, you can scale easy to VMs like auto scale and stuff like that as well. But in general, it's still easy to kind of wrap your head around when it comes to Kubernetes. And with namespaces offering what I would call soft multi-tenancy, now we have multiple applications running from different teams, could be from different departments, and they're all in this shared pot, right? Like, because what Kubernetes does is it pulls your resources, CPU, memory, GPU, and allocates based on requests and requests for the workloads. Now, how do you figure out which workload is costing how much, which workload is consuming how much, which workload is not using what it has requested? So it's suddenly there's another layer of abstraction on top of the VM. So that's a bit of a pain point. That's one kind of quick challenge that I would highlight. The other one is also, and this is a problem even when people are running VMs, deciphering cloud bills has always been a challenge, and that's something that if you talk to any any customer who's moved onto the cloud, that's one of their sort of like the number one complaints. How do we figure out the cost, right? So and now with Kubernetes on top of that, and it's a bit of a black box. It further compounds the problem. So one of the number one challenges is, if you take the cloud bill, how do you attribute it to your Kubernetes clusters, and then from there onwards, how do you attribute it further to your workloads, right? So that challenge is there. And then let's see if I missed anything from from sort of like the high level. Let's see.
Yeah, I
Which,
think we can drill down a bit into
yeah,
each
let's
of
do
the
that.
challenges,
Yeah,
right? But I totally agree with one of the points that you mentioned, because let us say someone is coming from a traditional virtual machines world,
yeah,
right? And if we compare to now, because in traditional virtual machines, what would happen is you have an EC2 instance, you know the hourly rate is set for you, you attach that to the team, and then you're done, right? But this is something that would not happen in Kubernetes, right? There are hundreds of containers, shared nodes, you have more components on top of your Kubernetes infrastructure. And one thing which is interesting here is, and this adds on to the complexity, is that the resource that you allocate are pooled and not dedicated to your cluster, right? All the workloads that you're running share the same pool of CPU and memory. So it's really hard for you to track costs per workload, like you mentioned, right? Attributing that cluster cost to each workload and how much your workload is actually costing you. I think this has also increased the overall complexity if we compare with traditional virtual machines environment, right? But I think while we are talking about this, right, people now would have definitely a lot of questions like, hey, what are the challenges, what are the roadblocks that come into the picture? So let's tackle each of the challenges one by one. And these are sort of the list of challenges that we feel organizations, and if you are someone who's interested to implement cost management in your organization, should be aware of. There can be more of these challenges, right? Different environments need different kinds of different there are different needs for different environments, but these we feel are the fundamental ones that you should be aware of. If you're listening right now, if there are any other challenges that you feel should be added to this particular list, and you have an experience to share with us, we would love to know. Just drop them in the chat and we'd love to have a conversation with you. But let's quickly drill down each of these challenges, Rajit, and talk about each of them in a bit detail, right? The number one is lack of proper visibility. And I think this is something we touched upon in the first webinar as well, right? Uh, and by visibility, what we mean to say is, if you are able to answer questions like, hey, how much is that particular workload, XYZ workload, costing you? Let us say if you had an increase in your cloud bill, are you able to tell which workload or workloads cause that spike, right? Or let us say which portion of your infrastructure is actually being used versus which is idle. So all in all, if you have answers to these questions in your organization for your infrastructure, then you are great. You already have that visibility that you need. But if you fall short and if you are not able to answer even like two questions from here, then there's a problem, right? You don't have that proper visibility. And proper visibility is important because before you start optimizing, you need that visibility, right? You can't optimize what you can't see. So just to tackle this really quick, Rajit, why do you think, because we are talking about visibility, why do you think visibility in a Kubernetes infrastructure is difficult even for mature teams? And what is the kind of visibility we are talking about here? Let's start with this one.
yeah, great question. I think it can be even boiled down to, like, you did ask the question, how much how much this particular workload is costing, right? But we can even take a step back and figure out how much is this cluster costing me. There is a way to figure it out from the cloud bill by using tagging strategies and stuff like that. But if you have multiple clusters, and there's a bill for your compute, there's a bill for networking, there's a bill for storage, and how would you know out of this cloud bill which, if you have clusters, let's say A, B, and C, how much does cluster A cost me? How much does cluster B cost me? How much does cluster C cost me? So that's kind of like, let's start from there. You can do some sort of stacking strategy to figure that out, but you gotta use your bill and do all kinds of number crunching and filtering to figure that out, right? So that's number one. So now let's say you figured out how much each cluster is costing. Next question is, like you asked, I have n number of workloads. How much does each of these workloads cost, right? How much does it cost to operate these workloads? And how much of that cluster is actually actively utilized by this workload? So idle versus allocated, right? And we talked about in the fundamentals. And then even answering questions like, I have, certain persistent volume storage attached to this. How much of those workloads are, how much of those, persistent volumes are actually actively being used? Because abandoned PVs is a bit of a problem. And some storage is expensive than others, like SSD. So we maybe have allocated it, but is someone actually using it? How much of that workload is actually, let's say you allocated 100 gigabytes, but how much of that is actually being used? Because sometimes people over allocate, and it's kind of hard to predict the how much you would need. So you need to leave a buffer, but sometimes it's drastically over provision. Or you can, and a workload may have used it at some point, but now that workload is gone and that particular PV is idle, right? So how do you figure that out? Another sort of challenge is network cost, right? We talked in detail about that during the cost fundamentals. You suddenly get an increase in your network cost, and now you need to figure out where is this traffic coming from, right? Like, who is driving this traffic? If first of all, which Kubernetes cluster is this coming from? Again, with a little bit of tagging and other things, you might be able to figure it out the bill level, at the cloud bill level. But once you come into the cluster, which workloads are driving it, right? And how much of that is egress versus cross zone versus cross region. So going into that level of detail. So it's kind of important to understand these things, and that's the level that I'm talking about. And then there are other interesting sort of questions that people have asked, right? Like customers have asked, say, hey, listen, I'm running a whole bunch of sidecar containers, and I've always wondered, how much does it actually cost me to run them, right? I have no idea, right? Like, is there an easy way to figure that out? So like, for example, you're running like Istio service mesh, it uses sidecars. How much does it cost? Or you're running some sort of APM tool that actually runs a sidecar. How much is that taking up from a resource perspective? If you look at the overall footprint, right? So there are these questions that people have, and trying to answer, at the most fundamental level. And then the other question that you asked was about increasing, like a sudden increasing cost. We talked about network, but how about compute cost, right? Like which workloads are driving it? So yeah, that having that level of visibility is important. That's the kind of visibility we are talking about, which we went into detail in the first webinar.
Interesting. You mentioned a lot of interesting points, and you mentioned about network cost, right? We discussed about what exactly do we mean by network cost in the first webinar as well. So feel free to check that particular one out too. But from what I understand is there, when we talk about visibility, there are a lot of different layers that we are talking about, different layers of visibility, right? The number one is at the cluster level. Then we drill down container level visibility, how your container is performing. Then you mentioned about network costs. There are a lot of overhead costs as well which are attached to it. Again, this is something that we have already covered in the first one. That's why the fundamentals webinar is pretty important, so make sure you check that out. But if we, let's say, zoom in on the cluster level view, right, because that's the first one, why do you think, what makes it really hard to break down the total cluster cost in Kubernetes? Is it mostly the idle cost, or is there any more complexity behind it? Because let us say, I'll tell you from where I'm coming from. Let us say if I'm a platform engineer, right, looking at my AWS bill, what stops me from easily saying, okay, here's my cluster, this is how much it costed me that month, and I can easily tell why. So what's stopping me what are the challenges, and what's stopping me to do that exactly from a cluster's perspective?
Right. So if you want to figure out the idle versus sort of utilized capacity in a cluster, you need a little bit more detailed information about the how much of that compute that is allocated to the cluster, how much of that is actually utilized by workloads, and this is which request or usage, whichever is higher. And the reason why we say request or usage, I mean, it's easy for people to understand usage, right? No brainer. But why request? The reason is in Kubernetes, and we talked in detail about this during the first webinar. In Kubernetes, when you request a certain amount of a CPU or memory and GPU, that workload will not get scheduled if the cluster can't satisfy that. So if there's auto scaling enabled, it will actually scale up in response to that, and then the workload gets scheduled. So now, because more capacity is allocated, or if you get allocated within the existing capacity that's reserved for you, some other workload comes, it can't use that. So now it has to, if it needs more, again, it's going to go, and auto scale, right? So whatever you have requested has a direct impact on your cloud bill, whether or not you use it. So if your request is higher than your usage, you have to look at the requests. If your usage is higher than that, then of course, alongside with that, you have HPA and other things, the clusters will start to, like scale in response to, more pods being, scheduled and stuff like that. But so you need that level of details to understand what is the actual utilization. And then you look at the idle capacity. So, this is the cost of my virtual machines, and this is how much is actually being used from a CPU, memory, GPU perspective, and then and the difference is my idle cost. And as we explained in the first webinar, if your idle cost is a little bit higher than 20% or so, it's you need to start looking at cost optimization, because it looks like you sort of have I wouldn't necessarily say the cluster is over provision, but there is opportunity for maybe you can shrink it down so that you can adjust the actual usage to what you're paying, because whether you use it or not, you're gonna it's gonna you're gonna pay at the end of the month, right? So understanding that fundamental breakdown is very critical.
I completely agree. Yeah, understanding the actual resource efficiency, how much you have provisioned, how much the workload is actually using, and the difference between the two. I think that's
Yeah.
really important to understand. And this is something we covered, and we'll be covering in one of the future webinars as well when we talk about right sizing, because that's an interesting concept too. But we talked about, you mentioned network cost, Rajat, right?
Yeah.
I feel that when we're talking about gaining that visibility, we often talk from the perspective of CPU and memory, but network costs are considered, in my opinion, as one of the quote unquote hidden costs, which teams sometimes may end up not looking at, right? Which shouldn't be, right? Data egress cost is, I would say, one of the highly underrated or hidden costs in the cloud bill, which a lot of teams often miss. So when we talk about from visibility perspective, right? What are some of the hidden costs that can be easily ignored in Kubernetes setups that often add to the complexity of gaining that initial visibility? Network cost is one that I can think of, and we already talked about it. According to you, what are some of the other such hidden costs that are get often ignored when we talk about visibility?
Gotcha. Yeah, network cost is definitely one, and in some cases, you might actually get a significant amount from a network cost perspective. So it will, it'll immediately grab your attention. But I think where the hidden part comes in is not understanding where it is coming from, like which workloads are driving it, and also the breakdown in terms of, especially in the Kubernetes cluster, like is this from cross zone versus egress versus cross region kind of thing. So like understanding that is important. What are the other sources, like you asked? So for example, we already talked about persistent volumes, right? Like that are allocated but not attached, because the cleanup policy, it's not specified to delete, and sometimes for good reasons, because you don't want your data to be cleaned up, right? But if there's a lot of workloads, especially a lot of people are running jobs and data science workloads that actually require faster storage, which is expensive, and sometimes the amount of storage is also pretty high. And if that doesn't get cleaned up afterwards, that can be a source of hidden cost for you. So that's one. The other sort of hidden source could be jobs. So we talked about this, data science kind of workloads. How much did this job cost me? You're running Argo workflows. How much did that cost me? If you're running something like a Tecton pipeline, and in some cases, the cost is negligible. But there are some customers who run long duration Tecton jobs for various other things, and that cost is not insignificant. So how do you understand the cost for temporary workloads, right? And so that's something that's a little bit challenging to figure out. Workloads that are always running, it's a different story, but temporary workloads, right? And then also this picture gets complicated a little bit when you have both spot and on-demand instances, or if you're using like Carpenter, maybe the same workload. Let's say I have a workload with 3 pods, and one pod may be scheduled in a larger VM which has higher cost, and the other two may be in different types of VMs, because with Carpenter, it tries to do efficient bin packing, and it looks at the whole picture and try to figure out what is the most efficient set of VMs that I can get to efficiently bin pack the workloads, right? So now the same workload itself has three, maybe 2 to 3. If you have 3 pods, you can actually have 3 different cost profiles, right? Maybe they're all on the same node. Maybe they're all on slightly different nodes, but it can have three. If you have 3 pods, 3 different cost profiles. How do you calculate that? How do you figure that out? So these are the level of detail that people have to deal with, platform engineers have to deal with when you accurately try to measure the cost. So that can be
Pretty
another.
interesting.
Yeah.
Yeah, pretty interesting. Thank you so much for sharing. I feel a TLDR version of this, I feel, is you need to ask these set of granular questions to yourselves, right? If you wish to gain that visibility. And that's why, because of these different layers, because of the dynamic nature of Kubernetes and different kinds of environments, that's why this gaining the proper visibility becomes a challenge. Now, how do you solve that challenge? That is a separate question to answer. We'll definitely tackle this in a future webinar. But for folks who are watching, I hope now you have a clear idea of the very first challenge that we should talk about, which was lack of proper visibility. And what do we actually mean by visibility, right? I hope that question is answered for you all. So let's quickly move on to the next challenge, which we want to discuss, is right sizing pitfalls, right? Now, right sizing, if you I hope people in the chat, if you already know what right sizing is, it is one of the most important strategies and most talked about strategies when it comes to Kubernetes cost management. But I feel it is important, but it is one of the most misunderstood practice in an organization, right? Because on paper, right sizing, it sounds really simple, right? You allocate just enough amount of CPU and memory to a particular workload based on the usage, right? It's really simple. It sounds simple, but in reality, it's a bit far from being just straightforward, right? So, Rajit, zooming out a bit in your experience, when we talk about right sizing, what do you think makes right sizing a challenge for teams today? And even when this idea sounds so logical and it's really important for you to implement.
Yes. So I think there are a couple of things that we've noticed on the right sizing side. One is lack of clear guidelines, and in the absence of guidelines, developers tend to overestimate. I've been a developer myself, and I think in the last webinar we showed this developer holding this oversized gun, right? And yeah, nobody wants their application to crash in production. So we tend to overestimate a little bit, and then that can lead to oversized or over provisioned workloads that is sitting there and costing money, whereas in reality it takes less CPU or memory, especially less CPU, to run that application. Um, Last week I had multiple conversations on this, and in one particular case, this gentleman who has done a lot of research into this, especially on the CPU side, he was doing a lot of research in what you called noisy neighbor detection. So as part of that, he was looking at CPU utilization a lot. And and when I said in my talk, hey, about 69%, right? About 60-69% is unutilized. So that means the utilization is 30 to 40%. And he said, that sounds about right, but I'm being very generous here, which means, like, he was actually saying in practice even lower CPU utilization. And CPU is an expensive resource compared to memory, right? So lack of clear guidelines is definitely contributing to it, because in the absence of it, developers will guesstimate, right? And then we always err on the side of caution. Second challenge is, now some organizations trying to combat this. They've come up with t-shirt sizing, right? Especially with this whole platform engineering thing. When you onboard an application, now you're giving a set of choices, right? Like alongside selecting git repo, all of these things, how much are you going to allocate to these workloads, right? So, and it's usually I've seen like things like small, medium, large, just to keep it less overwhelming for the developers. And when you're not sure, um, and there's no feedback loop, people will end up again, um, you know erring on the side of caution, and go with um, the more safer option, right? So in some cases where a medium size would work, they'll go for a large. Or in the case where a small sized VM is okay, they'll go for sorry, not VM, but a small sizing is appropriate. They might go for the medium size because of the fear of failure, right? So that's the second one. I would say, even when you have some level of guidance or guidelines, people tend to sort of overestimate. So those are some of the main sort of right sizing challenges that we have. And I think we will talk about the lack of feedback loop as a topic on its own. But I also think, like, it's also another challenge from the right sizing perspective is, in the absence of um, guidelines, or if you, let's say, you selected a suboptimal process, people tend to forget it because there's no feedback loop, right? So that's the other sort of challenge. We can talk about it in a little bit more detail after this.
Absolutely, yeah. You mentioned something interesting, which is t-shirt sizing, right? For folks who may not be aware of t-shirt sizing, what exactly is t-shirt sizing? If you can explain that with an example, and if we can again dial back on the point of why do you think something is missing in this approach of t-shirt sizing when we compare it with a dynamic approach of right sizing?
Right. So just to explain, my apologies, I should have explained this earlier. Let's say, most people are moving to microservices, let's say, and now when you onboard your application, the platform team will ask you, you need to give us some guidance on how to set CPU and memory limits, right? And the way t-shirt sizing comes in is just to keep the options limited, and not to overwhelm people. They will say small, medium, large, extra large workload. So is your workload a small workload, a medium workload, large workload, extra large workload, kind of like the t-shirts, right? So let's say the small workload may have for argument's sake, right, like 100 millicores, and 250 megabytes, right? The medium one might have, once, I don't know, half a CPU, so 500 millicores, and half a gigabyte, so 500 megabytes of the memory, right? And then the large one could be like one CPU, 1 gigabyte, and then extra large is a little bit more, right? So that helps the developer to kind of quickly set something. And then there's always outliers, right? Like there'll be cases where people will have requirements that it's outside of that. But what these platform teams do is they survey the microservices landscape, and talk to the teams and figure out what does it usually take. Can we come up with some standard sizing, because that helps them to bring some order to the chaos, instead of people selecting random amounts, right? Yeah, so that's the t-shirt sizing thing. But the issue is that um, nobody's checking whether that option is correct later on. I mean, you need to have some sort of monitoring feedback loop to figure out what you said is good enough. Is it too much or is it too little? There are cases where sometimes it's too little too. But in general, most developers will err on the side of caution and select a larger size, at least, to be on the safe side in the first iteration. So ideally, what should happen is, um, people should monitor it for a period of time and say, hey, listen, this is too much, let's dial it back down, right? So that's the problem, like without that feedback loop, this t-shirt sizing, while it may help bring some guidelines into place, it may be suboptimal.
Interesting. Yeah. So there are like, from what I understand, there are two very ends to t-shirt sizing. One is you provision, you take up like large amount of resources because just to be safe, and then on the other hand you may end up taking too less, right? Which is the problem of over provisioning and under provisioning, right? So yeah, you were saying something.
Or you end up in the middle, right? I mean,
Yeah.
depending on how you do this t-shirt sizing, sometimes you find these workloads that are like kind of neither here nor there. So what do? They size up, right? Nobody goes one size down. So things like that. It's a little bit difficult, for the teams. Yeah.
Interesting. Yeah. And that actually, we were talking about this as well. You mentioned a point that brings us to the third challenge, which is feedback loops, right? You mentioned this again and again. And I like to emphasize on this. This is another critical gap that we feel. So even if, let us say, teams have these set of right guidelines to right size, the real challenge is keeping the process continuous, right? Because right sizing, because the workload usage fluctuates, and with that fluctuation, your sizing or the amount of CPU and memory you give, that decisions will fluctuate too according to what you're using, right? Let us say a team right size based on 1 week of how the workload is being used, but 3 months later the workload has changed, the usage has changed, so the same number may not be applied 3 months later, right? So you need to keep that in mind. And this is something that is again a critical gap that we have seen in conversations. So Rajit, why do you think having such continuous feedback loops like you are seeing in the screen here uh, often are missing when organizations are trying to implement right sizing, right? And according to you, what could be the risks or potential drawbacks of not having these continuous process of right sizing, even if you have set clear guidelines to right size?
Yeah, so let's start with the most basic. So when you first deploy a application, a set of, like let's say you're deploying a new service, it's a little bit harder to figure out. Like, I mean, you do capacity planning, and you do testing, you do performance testing. Ideally that should be the you sort of like the first thing you should be doing. How do you, at least come up with a reasonable guesstimate, is to do um, performance testing and capacity planning, right? um, in general, people test with at least 1x of performance, 1x in production load, or generally most people do, 1.3, 1.5, 2x, because there could be a burst. So now you look at all those variables and then figure out, okay, this is going to be my sizing. And then the more mature teams will also look at, pod count, right? So they'll configure something like CADA or HPA so that they can scale automatically, right? Because if you're getting a variable workload, we'll talk about that, in a separate section or in a segment as well. But you need to figure out those. You have to make those decisions, right? So the first way to do that is have some sort of capacity planning through performance testing, and now you come up with some sort of sizing. And then when you come up with that sizing, that's where I mentioned that developers will tend to a little bit overestimate, because they want to play on the safe side. So now you get that deployed, and the issue is if you don't have a good feedback loop, that's like a one and done thing. People forget about it. If something crashes and there's memory issues and CPU performance issues, then people will go back and try to increase that happens. But the other way around rarely, like people rarely revisit, right? Like, I mean, if things are not crashing or there's no issues, nobody's going to look at it. Hey, can we actually reduce the amount? And if your workload is very, like, highly, it's fairly over provision, you're actually incurring a cost that you could save otherwise, right? So going back and at least revisiting the performance metrics, revisiting the usage metrics, the efficiency of your workload, can help you lower your cloud bill in the case where you have, the estimations you made were a little bit off, right? Or sometimes, value, like, there's a pretty wide gap. So that's the first sort of point, like, and that can apply to any kind of workload. The second one is what you exactly mentioned. You initially, like, you deploy, and maybe you're happy with it, but as your business grows and as your workloads change, the nature of the workloads change, things can start to, like, the resource requirements could change too. So now your workload might be requiring more resources, and what you started with may not be adequate. So now it's starting to become a performance issue, right? Or it could be that if you don't monitor the usage, it could be that, like, from a performance perspective, you may have introduced some sort of issue, and generally, that will show in most of the time. It's, my experience is it's memory leaks and other things. I mean, there could be cases where, you've written something very inefficient that chews up a lot of CPU. That can also happen, but more often than not, it's some sort of a memory issue, and suddenly your new workload has more memory. Now you may be monitoring from a performance perspective, and that feedback loop should somehow come back to the team that is also thinking about cost. The reason is, though, when then there is an issue like that, temporarily what you may end up doing is give it more CPU, give it more memory until the development team finds a fix, right? But once you fix that, though, that has to come down after you monitor it for a little bit. So that kind of constant feedback loop is required, because it, like I said, the nature of the application can change. It could be that usage has gone up. It could be that there is a performance issue. It could be that as you bring in other microservices, the behavior patterns may have changed. So it's not like a one-time thing where, what, I'm going to give it one CPU and 1 GB, and that's the end of it. That usually leads to either inefficiency. So the drawbacks are, either you're paying more than you should, or your application is going to have some level of performance issues. So there's, the damage can be on both ends, either cost or performance issues.
Yeah, I think again we come to the discussion of balancing cost and performance, right? And that's how you do correct right sizing. And again, something which we are going to discuss later in another webinar too, because this is one of the most important topics. But this made me actually curious, right? Because you mentioned that, when we talk about feedback loops, right, uh, what happens is you end up setting some values right now, and then you forget about them, and then something breaks, something happens, and then you need to revisit the values again, right? So if the feedback loops are not set. But I'm curious to know exactly, why, what's the reason of not revisiting these resource allocations regularly? Is it due to maybe lack of time? Is it maybe lack of tooling, lack of ownership? According to you, according to the experiences and the conversations you have, what is the common reason of not doing this regularly, not having these regular feedback loops?
I think it's all three. It's actually a great question. I think that's a point worth highlighting. Um, First of all, lack of tooling and visibility is a problem, and but that's half the problem. Like you can buy some product, you can buy the Randoli cost management, and have that, but that's only going to solve one part of the problem for you. Most teams are really pressed with time, so may or may not have the time to actually go through the recommendations, look at those things. So definitely, lack of time is definitely a problem, and then lack of ownership, right? You can have the tooling, you can have the data, but someone has to take ownership. Someone has to think cost management, right? I think a lot of larger organizations these days have a FinOps focused person, because their mandate is to actually look at how can we improve the bottom line, like how can we improve our operating efficiency, and how can we reduce cost. So I think a lot has to do with a culture of ownership and a focused mindset on this. I mean, especially when we talk about DevOps, it's a pretty common thing to say that DevOps is not a title or a set of tools. DevOps is a mindset, right? The tools will only solve part of the problem. You need to have that culture of cost consciousness, cost awareness, being everyone being aware of it, and then some folks taking on the responsibility. And I mean, we are a startup too, and this is something that we carefully keep an eye on, because it's important for everyone, whether you're a small organization, a large organization. Have someone take ownership, look at your cloud bills, look at the utilization, look at the right sizing opportunities, right? All the tools can give you the data, but someone has to take ownership, drive it, act on it. And that's, if you only do both those things, you can actually reduce the cost, right? Otherwise there's no point. And sometimes people want to do it, but they don't have the right tooling, right? But I think in general, though, getting the right tooling um, is easy. That's the easy part. The hard part is actually building that culture of ownership and people taking action, timely action on the data points that they get. Yeah.
Completely agree on this, and the lack of ownership is something we are going to discuss right now, which is the next point in our as a challenge. But I think it's clear now that right sizing is not just a one time thing, you do it and forget it, right? It's a continuous process that you need to do. But many teams struggle on both the ends. They either don't know how to start because they don't have the clear guidelines, which we covered in the first point, and even if they do, even if they have the right set of guidelines, they don't end up following through because there is no feedback loop to validate and adjust the values according to how the workload fluctuates over time, right? So either way, you are impacting the cost and you're also impacting the performance, right? So those two go in hand, right?
Right.
But yeah.
May I, before we move on to the next section, I forgot to mention some other thing which might be of interest to some of our audience. Not it's not an issue for every type of startup or organization, but definitely for certain categories of customers, right? So we did, you and I talked a little bit about how the workload evolves as the business evolves, or you make more fixes, or you put in more microservices into the mix, the interaction. uh, that's something that every organization will go through, but there are other challenges that some type of organizations would go. For example, like a retail customer, uh, you know uh, a customer who's in the retail business, they have massive seasonal variations. So, meaning the right sizing that they do in some months are completely off when it comes to, like, the holiday season or Black Friday. I've worked with customers where their Black Friday load is 10 to 15 times compared to their average load otherwise. So how do you right size in that kind of situation, right? There are other customers who have a little bit more predictable variations, like could be financial institutions, others where they have towards the end of the month, maybe because people are checking more, the paychecks are coming in, people trying to pay bills, they have a surge towards the end of the month. Or if there are like certain holidays where people have more of a need, so like a little bit more predictable, but still a significant variance. And then there are customers who have daily variances that no static right sizing can support. Like for example, a ride sharing company, they have a morning peak hour to deal with, then they have the evening peak hours to deal with, and sometimes weather related patterns, like like a snowstorm or a thunderstorm suddenly causing people to avoid trying to drive and try to take a ride sharing option, right? And then suddenly it spikes. And so there are known patterns, and there are also like sudden unpredictable patterns, like weather. Nobody can predict the weather. So how do you do right sizing in those situations, right? Like there are, I mean, one thing to talk about is that HPA can handle those things, those sort of variations. But for some folks, that is not good enough. They need to, for the more predictable patterns, can they scale ahead a little bit earlier? So right sizing for some of these use cases that I talked about is definitely a little bit more complex and nuanced, and they need to employ different strategies. So if you're one of those customers, we would love to, or rather one of those users, we'd love to hear more from you about these patterns, because you need to employ slightly different, you have different challenges, and you may need different solutions for that kind of situation. And for those customers, this kind of visibility is really important. So I thought I'd kind of mention that, because I forgot to mention it when we discussed the actual challenges of right sizing and the missing feedback loop part.
Absolutely. It's great that you mentioned these, because this clears the picture a bit more as well, right? You have some unconventional and unused, unrecognized patterns. And I think doing right sizing definitely ties to having that proper visibility. If you don't have that, then you won't be able to recognize such patterns in the first place, right? So in my opinion, these challenges that we are talking about, we have two more challenges that we are going to talk about very quickly, right, because we are short on time. But I feel that these are very much tied together, but everything starts from having that initial visibility. If you don't have that, then things become a bit more difficult. Let's quickly jump on to the next one, right, because we are a bit of short of time. But Rajit, you have mentioned about lack of ownership, right? Which was, as you mentioned, one of the major challenges when it comes to implementing a feedback loop, right? That continuous loop. So even if you have that visibility, and teams are trying to right size, there is still one fundamental blocker that keeps coming again and again, which is who's responsible for it, right? And the lack of ownership. Because in Kubernetes, what we have seen is infrastructure is shared and multiple teams are running workloads on the same cluster. So, and what we have seen is, and correct me if I'm wrong, Rajit, common services which are being used are often handled by the platform teams, right? So when a bill, let us say, spike, you saw a spike in your bill, everyone tends to look at each other and tries to figure out like who should fix it and who is responsible, right? Just as the meme shows, right? The platform team is blaming the developers tend to point towards the platform team, right? So there is this lack of ownership of which team is attributing more cost and which team is costing you more, which in my opinion creates friction, and more importantly it delays the actual action. So at the end of the day, your cost and performance gets impacted in real. So why do you think this there is this problem of accountability, and why do you think in Kubernetes this is a bit tricky to implement, and why is it important to implement in the first place in cost management?
Right. So we'll talk about why it is important to implement in the first place, and then we'll talk about why it is difficult. So First and foremost, there is also an accounting problem. So, especially in larger organizations, they are trying to figure out how much each application costs, how much each business unit costs, how much department costs, depending on their. It's a business level thing, so it's an accounting problem. How do I account the cost of running my applications, right? So there is a business problem there. The second sort of problem is in terms of also in terms of capacity planning and other things, understanding is more like an operational sort of challenge as well, trying to figure out how much each team is using, what services are they using, like you talked about, like common services and stuff like that. So figuring that part out and understanding ownership, not just from a cost perspective or an accounting business perspective, but also from an operational perspective, right? Like this team is using more of these services. Maybe that team is like the application portfolio is growing. How do we better support them? So there's both business and accounting operational challenges that they have to um, solve, and so that visibility is important. On the business side, people call it like chargeback, so internal chargeback, yeah. And or you actually could be running a managed service with external customers. How do I bill my customers in a more fair manner? With Kubernetes, I talked about, you can do, soft multi-tenancy, and then, you can wall off a set of namespace using network policies and stuff like that. So now how do I figure out how much each custom is costing me, so I can bill them more appropriately? So there's, both that business accounting challenge as well as operational challenges that can be both external facing or internal facing, right? So those are the challenges. Why is it difficult? We talked about it right at the beginning a little bit, which is, it's a shared pot, and soft multi-tenancy. Now you have a bunch of applications, all in that same pot. How do you attribute cost from a resource perspective? These applications are using X amount of CPU, memory, GPU, and hopefully you can measure the network as well. There are tools to do that. And now, how do you figure out the cost? So without adequate tooling or visibility, it's hard to figure that out. If you do the VM route, right, you can dedicate VMs for certain teams. You can dedicate VMs for certain customers. So it's easier to um, have that breakdown. But in the Kubernetes world, because it's a shared pod, in the same VM, you will have multiple customers running because of, you can do implements of multi-tenancy. How do you figure that out? So that's the challenge that Kubernetes brings in from this accountability perspective. And then not only that, there's another aspect to it that you mentioned, the shared services. So for example, the kube system, maybe you're running some sort of observability tool that takes up a namespace. You're running some sort of a different sort of fundamental thing, like let's say you're running an API gateway, or you're running some other service that is utilized by multiple groups or multiple applications within that cluster. How do you apportion that cost to these different teams, right? More or less like the chargeback cost. Then there's also the control plane cost that is costing this. So should the platform team absorb it? Should the platform team, does it come out of the platform team's budget, or should the platform team take all those overhead costs and then figure out how do I build internal teams? Like how do I apportion that cost? So there's this set of questions people need to answer. And in the Kubernetes world, it's a little bit difficult to figure this out. There are ways to do it, of course, but that's the challenge because of the nature of how everything is. With that level of abstraction comes that sort of added complexity there.
It's interesting. You mentioned about cost accountability, right? Even what I feel is, even though the resource consumption is driven by the application team, right, the developers, the cost accountability part gets often pushed towards the platform teams, right? Simply because they are the ones who are managing the infrastructure. So let's take a moment to sympathize with the platform team for a bit. And do you think that in the end of the day, platform teams are, end up taking too much burden on their own shoulders right? Which sort of creates this tension and between the developers, and this whole problem of accountability and ownership. And at the end of the day, you're not able to fix the actual issue. What do you think about that?
Yeah, 100%. I think we did talk about that mindset, being cost aware, that shared responsibility, and I think one of the key things that will come out of this accountability aspect of attributing cost, it's yes, it's good for accounting, business, and operational side, but it's also a way for the platform teams to promote awareness and responsibility within the teams understanding this is how much it's costing to run my application, this is how much it this is my resource utilization efficiency. Maybe I need to do something about it, right? I think most people, when you present them with the data, they will try to respect that and try to improve. So accountability, like to build that kind of culture of shared ownership, and people being responsible. It's good to have the numbers and provide them so that the teams can share in that burden. But otherwise, it's on the platform team to reduce the cost while having this battle with the developers. And I think for the platform team, if you're a platform engineer, and the best way to deal with this situation is to have the data, to have the numbers, so you can say, hey, listen, you have requested X amount of resources, but you're only using Y, right? So your efficiency is, I don't know, at 50%, 30%, or could be 60%, right? Maybe you could do a little bit more here, and improve this. Let's reduce something, right? Or because sometimes, especially platform engineers get hit with this. If there is a issue in production, right? Number one thing sometimes the developers will say is, let's increase memory. That's why there's a performance issue, right? Let's give it more resources. Maybe it needs more CPU. Maybe it needs more um, memory. But if the platform engineers have the data, hey, listen, it's only using this amount of CPU, this amount of memory, right? We've already allocated X amount to the pod, right? Look at the efficiency of it. It's barely using it. So that's not the reason. So it's the this is not just a cost saving way, a mechanism, but it's also a way to kind of and look at performance side of things as well, right? Like that's why we think there's a like when we talk about unified observability, cost management, you can't just do it in a vacuum. Same with performance optimization. There's a cost implication, and a performance, because it's two sides of the coin. So having this data helps the platform engineers to make the case that this is not about just adding more CPU and memory, because it does come at extra cost, right? Like I've seen this many times where the engineering team is like, no, we need to increase this. That's the way to solve this problem. And the platform team, in the absence of the data, is caught between a hard place and a rock, and they're like, you know what, let's increase it, because these guys are claiming this is the case, this is why this, or this is the cause of it, right? But if it is not the actual reason, and there are some cases which is the reason, if it is not that increases your cloud bill. So there's a direct impact on cost. So this accountability aspect, this challenge, if you solve that, it can help to not just keep the costs down, but it's also a tool to reduce friction, like you said, between platform teams and developers. Because now, instead of arguing based on emotion and gut feel, you are having a sane conversation based on numbers, right? That goes a long way. And I mean, it's large organizations, there's always politics and other things as well. So the less we deal with emotions and gut feel, and we deal with actual facts and figures and hard numbers, it helps promote more clear, friendly communication, because the numbers don't lie, right? So that's why I think it's an important aspect of it.
I think you summarized it really well, right? Instead of playing that infamous blame game,
Yeah.
It's important to focus on the actual data and the actual numbers and make the decisions based on that. And again, circling back to the point we mentioned, it's not always about the tooling. It's often, it could be an accountability problem, right? That's why you have the roadblock in implementing the right strategies. But just let's quickly touch upon the last challenge of today, because we have been going on for more than an hour now. We have crossed the hour mark, but I hope the people who are listening till now are gaining value from what we are sharing. We discussed four major challenges now, and I feel this last one is very much relatable to a lot of people. Even if you're a developer, even if you're in a platform team, when you talk about going multi-cloud, right, and we talk about hybrid environments, because that is a common approach that organizations are doing these days, because it gives flexibility, it gives you high availability, right? But it often adds to the complexity as well, right? Because there are different pricing models, different billing structures of different cloud providers. So just to quickly touch upon this point, Rajit, because this is very much this particular challenge will be very much resonated with the platform teams and the developers alike, in my opinion. In your experience, how much harder does cost management become when you are operating at a multi-cloud and at a hybrid level? And according to you, because the perspective from where I'm coming is, if you are already struggling, if there is already a challenge of you having visibility and ownership in a single cluster, how does that those particular challenges multiply in multi-cloud and a hybrid setup, if we can touch on that?
Yeah, great question, and it's something that we've had to deal with too, because we have production environments in all three clusters, where because of our marketplace listing. So it's a challenge that we face too. Like you said, like everybody has a slightly different billing format. The way the cost is shown is different. So imagine me having to look at three different cloud bills. We are on GCP, AWS, and Azure, looking at three different cloud bills every month and having to decipher, you know, why cost is different from one versus the other. Is it because of usage? Is it because of something else? Do we have the, like, what's the utilization on each of these things? It's a little bit difficult for decision makers and platform teams to kind of wrap their head around by just looking at these different cloud bills, right? So you probably need some sort of tooling that can bring a more consistent um, approach or consistent interface to help see this in a more structured manner, right? So and the one good thing about this with in our case is Kubernetes. So we can come up with a more common, consistent structure. In this case, Kubernetes is helping by bringing it to something that's a little bit easier to put together, right? So I think the other situation is some people have hybrid setups, on-prem versus cloud. On-prem, it's a sunk cost because it's a capital expenditure. You've done the hardware purchase. The cloud, it's a variable model. So again, different sort of models, right? Cost models as well. So how can you bring that into a more easy, structured manner? So let's say you're the VP of engineering, or you're a CTO, or you're looking at, you're the FinOps person, and you want to look at the last month, the previous month, or last billing cycle, previous billing cycle. How do I wrap my head around the cost, right? Like, if I look at all of these different platforms, how do I figure out, has the cost gone up, has the cost gone down, what is the breakup when it comes to the different Kubernetes clusters, how has the CPU memory increased? Like, if you're just presented with three cloud bills or some Excel spreadsheet, you may have to do the mental math yourself and look at these things. And some organizations actually spend a lot of time preparing the data and the graphs to the management team, because you need that data to figure out, right, like how much it is costing, because they need for planning and other purposes. So having definitely the multi-cloud hybrid setup has complicated the picture. That's a big challenge. But by using Kubernetes as the common mechanism, you can bring some sort of structure to how you look at it. Um, it's definitely a challenge. So that's a good way to kind of, I guess, wrap up the conversation. It's this is a challenge that I think, not limited to large organizations, even like a startup like us is facing this, or maybe in certain regions, it is, for certain industries, cloud exit and having multi-cloud strategy is a bit of a mandate. Like if you look at the European region and stuff like that. So this problem is something that's going to be faced by a lot of organizations, not just larger organizations. We've met several startups actually having to deal with this problem.
That's interesting, and thank you so much for sharing such insights. And I know that we are going to talk about solutions in the next set of webinars, but I feel that if you are focusing on a multi-cloud setup, I feel a unified view of all of your different cloud environments, having that tooling, the right tooling, I believe, is something that could definitely help you to curb this particular challenge. And as you mentioned, if you're using Kubernetes, you have an advantage. You have some ways to structure this particular data in a way that makes sense, right? And again, we are going to talk a little bit more about how we do this. But as you mentioned, right, we are at the end, folks, of this particular webinar. I know we covered a lot of different points today, and we particularly covered the main four challenges. Just to quickly recap all the challenges we covered, we first covered what are the visibility gaps, right? Lack of proper visibility, why is it important? What visibility we mean, right? Then we talked about right sizing, where we talked about how you may lack set of clear guidelines, how you may not have some feedback loops, because right sizing is a continuous process. That is also another challenge. We talked about the lack of ownership, right, which creates friction between the platform teams and the developers, which again impacts your cost and the performance. And last, we talked about going multi-cloud and hybrid, right? What are the challenges which are involved? So I believe, Rajit, these would definitely give everyone a good picture of what are the roadblocks on the path of, if you are someone who is trying to think and trying to implement Kubernetes cost management is in your organization. And just to remind everyone of this particular series again, this was the second webinar. You can scan this particular QR code to get access to the first webinar that we did. Again, the recording for this one will be available shortly on the same playlist as well once you scan this QR code. And in the next set of webinars, we'll talk about what are the actual strategies that you can implement to tackle all of these challenges, right? And some more, right? So this is what we are going to talk about from the next set of webinars. Feel free to ask any questions that you may have after the webinar. I know we are short on time right now, but feel free to reach out to us, me and Rajit. And if you want to stay connected with these webinar series, I would recommend following our social handles as well, right, on LinkedIn, on Twitter, wherever you are joining us from. But again, all of the important links I'm mentioning would be available in the recording on YouTube in the description box. So feel free to check that out. But Rajat, before we close off for today, do you have any ending thoughts for everything we discussed in this particular webinar?
Um, because we're short of time, I'll keep it pretty brief. I think, if there's two things that comes out of this is, one is, having the visibility goes a long way. So understanding the like how your workloads are, like how much your workloads are costing, getting your head around the how much each Kubernetes cluster is costing is important. And then once you have that visibility, I think the second thing that can make a difference is building that culture of responsibility and awareness. So the tools will solve one part of the problem, but as an organization, as a team, you need to take responsibility to promote a culture of cost awareness and ownership, uh, and people taking actions. Because otherwise, I've seen the tools are spitting out data and details, but nobody's acting on it. So you need both sides. So think tools to gain visibility and awareness, and a culture of ownership and responsibility that actually acts on it. And cost management only works if you have both, right? As a vendor, we would love to sell you cost management, but it's you're not going to get the benefits if you don't have that culture of ownership and awareness, where you actually go ahead and implement these suggestions and solutions.
Couldn't have summarized it better than you, Rajit. Thank you so much again for joining me in this webinar, everyone, and thank you so much, Rajit, for taking out your time for this. And yeah, I think we'll see everyone in the next set of webinars.
Yeah.
Bye bye.
Thank you everyone for joining us. Hope to see you in the next webinar. Thank you. Take care.
Take care. Bye bye.